Hello friends, in this video we shall see system of linear equations, how to solve that system by using matrix notation. Dear friends, as we are uploading the videos of whole matrix algebra and we are also giving the notes on this topic with a group, subscribe the channel and don't forget to press bell icon to get updates from the channel. Now we shall see which elementary row operations we can use on the matrices. First operation is replacement operation. Replacement operation is nothing but replace one row by the sum of itself and the multiple of another row. Replace one row by the sum of itself and the multiple of the another row. That means Ri plus k times Rj means multiply every element of jth row by element k and add it to the corresponding element of ith row. Second, interchange two rows. That means interchange ith and jth row. It is called as Rij. Interchange ith and jth row. And third operation is a scaling. Scaling means multiply all entries in a row by non-zero constant. That means k into Ri. Every element in ith row can be multiplied by a constant or by a scalar number. Thus, we are using these three operations in matrices. First is replacement, second is interchange, and third is scaling. Replacement is nothing but multiply every element of one row by some number k and add it to the corresponding element of ith row. That is Ri plus k times Rj. Second, interchange means interchange the any two rows, ith and jth row. Every element of ith row can be placed in the place of jth row and every element of jth row can be placed in the place of ith row. Scaling. Scaling means nothing but multiply all entries in a row by a non-zero constant. Row operations can be applied to any matrix, not merely to one that arises as augmented matrix in a linear system. Two matrices are called as row equivalent. We shall define row equivalent matrix. Two matrices are called as row equivalent if there is a sequence of elementary row operations that transform one matrix into another matrix. Suppose A is a matrix and if we apply some row operations on that elementary row operation, that means any one of the three operations or any of the three operations, and we obtain the matrix B, then A and B are called as row equivalent matrices. That means if we apply operations on a matrix, get another matrix, then it is called as equivalent matrices, row equivalent matrices. It is important to note that row operations are reversible. If two rows are interchanged, then can be returned to their original position by another interchange. Suppose we interchange ith and jth row. Then to reverse, again replace this jth row to the place of ith row and ith row to the place of jth row. Thus you will get reversible operation. If a row is scaled by non-zero constant c, then multiply new row by 1 by c. If we multiply Ri by k, then its reverse operation is 1 by k times Ri original row matrix. That means if we multiply every element of ith row by k, then for reverse transformation, you have to multiply every element of that row by 1 by k. This Ri is newly obtained row. Finally, consider the replacement operation involving two rows, say R1 and R2, say rows 1 and 2, and suppose that C times row 1 is added to row 2 to produce a new row 2. To reverse this, the operation add minus 3 times row 1 to new row 2. That means R2 plus C times R1. This operation you had applied and obtained a new matrix. Then to reverse the transform, what you have to do? You have to multiply this row by minus C and add to newly obtained R1. That means R2 minus C times R1. This is the reverse transformation of R2 plus C times R1. If the augmented matrices of two linear systems are row equivalent, then the two systems have the same solution set. When the two systems have same solution set, the augmented matrices of two linear systems are row equivalent. That means one matrix can be obtained from second by using elementary row transformations. Existence and uniqueness questions, whether the solution is exist or solution is unique. Why a solution set of the linear system contains either no solution, one solution, or infinitely many solutions? This is the first question. Answer to the following two questions will determine the nature of the solution set for a linear system. To determine which possibility is true for a particular system, we ask two questions. That are the two fundamental questions about the linear system. Is the system consistent? That is, does at least one solution exist? And second, if the solution exists, is it the only one solution? That is the solution is unique? That means for every problem, we have two questions in our mind whether that system is consistent. System is consistent if it has a solution, at least one solution, or it has more solutions. If the system has solutions, then it is said to be consistent. And if solution doesn't have any solution, then it is called as inconsistent system. First question in our mind is the system is consistent? Second question is, if the solution exists, is it unique? Is the solution only one or there are infinitely many solutions? These two questions are the fundamental questions we shall learn by solving a problem. Determine if the following system is consistent. How to check this? For that, we shall write augmented matrix of this system. In our last video, we have learned how to write augmented matrix. Augmented matrix A, P can be written as in first row coefficients of variables in first equation 1, minus 2, 1 and 0. In second row coefficients of x1, x2, x3 and constant term of second equation 0, 2, minus 8 and 8. In third 5, 0, minus 5 and 10. This is the augmented matrix constructed from this system. Then the system is consistent if rank of augmented matrix AB is equal to rank of the coefficient matrix A. Coefficient matrix A is this much matrix is coefficient matrix. This is the coefficient. If rank of this matrix and rank of this whole AB augmented matrix is same, then we can say that the system is consistent. Now we shall calculate the rank of this. For calculating rank of this, we shall try to make this matrix as a triangular matrix. That means we shall apply the row operations and try to make the elements below diagonal 0 and diagonal elements 1. The first element must be 1, and by using that first element 1, we shall try to make these two elements 0. Element below that one, we shall try to make they are 0. But in second row there is 0, therefore no need of making 0. In third row, we have to make this 5 0. How we can make this 5 0? We shall apply R3 minus 5 times R1. If we multiply first row by 5 and subtract it from third row, then this element becomes 0. Other two elements will remain R3 minus 5 R1 to this. And then we will get first row will not change. We shall write it as it is. Second row also as it is. We have to change only third row because we are applying on operation on third row. We have to multiply by 5 to this. Therefore, 5 minus 5 into 1, 0. This second element 0 minus 5 into minus 2, that is a plus 10. This minus 5 minus 5 into 1, that is again minus 10. We get this matrix, and we have to make R3 minus 5 R1. Therefore, we will get matrix this. First row will not change, second row will not change, and third row will become this. Now, we have to make this second element 1. Therefore, how to make this second element 1? Divide this row by 2. If you divide this row by 2, then you will get that element 1. For that, you have to make 1 by 2 R2. This operation you have to apply, and you will get only second row will change 0, 1, minus 4, 4. And for third row, we shall apply 1 by 10 R3. For third row, 1 by 10 R3. And that will becomes 0, minus 1, minus 1, 1. And then to make that element 0, we shall add R2 and R3, and that becomes like this. Third row becomes 0, 0, minus 5, 5. And then operate 1 by minus 5 R3. If we apply that minus 1 by R3, first two row will same, and third row will become 0, 0, 1, minus 1. See, this is a diagonal matrix. And here, what is the rank of this A? A means these three columns. Rank is nothing but number of leading ones. Number of leading one in this are 3. This one is there. This is second leading one. This is third leading one. Therefore, row of A equal to 3. And row of AB. What is row of AB? It is also 3, because it also has 3 ones. Therefore, it is 3. And since row A equal to row AB, the system is consistent. System is consistent means system has a solution, either one solution or infinite solution. System has solution. This indicates. Therefore, system is consistent. Now, we shall try to obtain the solution. We have determined system is consistent. That means solution exists. Now we shall try to obtain solution. From this matrix, we shall write the equations. The first column is for x1 coefficient, second column is for x2, and third column is for x3. Therefore, from first row, we will get 1x1 minus 2x2 plus 1x3 equal to 0. This is the first equation. From second row, we will get 0x1 plus 1x2 minus 4x3 equal to 4. And from third row, we will get 0x1 plus 0x2 plus 1x3 equal to minus 1. Here it should be 1. 1x3 equal to minus 1. And hence, we will get x3 equal to minus 1. If we put this x3 equal to minus 1 in this second equation, you will get a2 minus 4 into minus 1 equal to 4. x2 minus 1 into minus 4 is plus 4 equal to 4. Therefore, x2 equal to 4 minus 4, that is 0. Now you get x2, you know x3, and if we put these two values in first equation, this equation, you will get x1. x1 minus 2 into x2, 0, plus x3 minus 1 equal to 0. This term is 0. Therefore, we will get x1 minus 1 equal to 0, and hence x1 equal to 1. Hence, solution is 1, x2 0, x3 minus 1. 1, 0, minus 1 is the solution of this system. Thus, we can check from this matrix whether the system is consistent or not. If the rank of A, that is first matrix containing 3 columns, rank of A equal to rank of augmented matrix AB, then the system is consistent. If rank of A and rank of augmented matrix are different, then system is inconsistent. At this point, we know x3, where we to substitute the values of x3 into equation 2, we could compute x2. We had seen that, and hence could determine x1 from equation 1. So solution is exist. Hence the system is consistent. In this way also we can check. Now second example, determine if the following system is consistent or not. Same procedure we shall apply. System is given as x2 minus 4x3 equal to 8, 2x1 minus 3x2 plus 2x3 equal to 1, 4x1 minus 8x2 plus 12x3 equal to 1. This system is given. We shall see this problem. 0, 1, minus 4, 8, 2, minus 3, 2, 1, 4, minus 8, 12, and 1. We have to make this first element non-zero. Therefore, we have two choices, either transfer this second row to here or transfer this fourth row to here. If I transfer second row to first place, that means R12, if I apply R12, I will get 2 minus 3, 2, 1. 2 minus 3, 2, 1, 0, 1, minus 4, 8, and 4 minus 8, 12, and 1. Now I shall try to make this element as 0. For that, R2 minus 2R1. First two row will be as it is, 2 minus 3, 2, 1, 0, 1, minus 4, 8. First two row will remain as it is. Only third row will change, and we are adding 2 times elements of R1 to third row. That is 4 minus 2 into 2, 0, minus 8, minus 8, minus 2 into minus 3. That means minus 8 plus 2 into 3, 6. That is minus 2. This row, 12 minus 2 into 2. 12 minus 2 into 12 minus 4, 8. And 1 minus 2 into 1, that is minus 1. Thus, we have made first element non-zero and element below that 0. Now, make this A2 element, that is second row, second column, and 1. This is 1, no need to do any operation here. Then, by using this one, try to make this 0. For that, you have to use R3 plus 2 times R2. R3 plus 2 times R2. First and second row will remain as it is. We shall write it as it is, 2 minus 3, 2, 1, 0, 1, minus 4, 8, 0. Third row 0 minus plus 2 times 0 is 0. Minus 2 plus 2 times 1 is 0. 8 plus 2 times minus 4, that is 8 minus 8 is 0. And minus 1 plus 16, that is 15. Now I want to make leading element non-zero. What is a leading element? Leading element is nothing but the element, first non-zero element in that row. Here, as these three elements are 0 in this row, we have to make this element 1. It can be make 1 by dividing 15. 1 by 15 are 3. We shall keep first two rows as it is, 2 minus 3, 2, 1, 0, 1, minus 4, 8. And if we divide by 15, 0 by 15, 0, and 15 by 15 is 1. See, what is a rank of A? Rank of A is a 2, because rank A is nothing but first three columns. Rank of A is a 2. And what is the rank of whole matrix A augmented B? This is, there are three leading elements, 1, 2, and 3. Therefore, rank of augmented AB is 3. Rank of A is a 2. Rank of AB is a 3. The rank of A is not equal to rank of AB. Therefore, system is not consistent. System is inconsistent, and hence system has no solution. We can check in this way also. The augmented matrix is now in triangular form, and we can write the equations from that, and we can see that from third row we will get 0 equal to 15. 0 equal to 15 is never true, and hence system is not consistent. In this way also we can check. We can check by using the ranks. We can check by deciding the rank, or in second way we shall construct the equations from this system, and we will get one equation, third equation, as 0 equal to 1 or 0 equal to 15, and hence system is 0 equal to 1. This is not true, and hence system is not consistent. One more example. The augmented matrix of a linear system has been transformed by row operation into the form below. Determine if the system is consistent. This system is consistent because this is a triangular matrix, and this A matrix, that is first part, 3 columns, has a rank 3 because there are 3 leading non-zeros. This is first leading non-zero, this is second leading non-zero, this is third leading non-zero. Therefore, rank of A equal to 3. Now, while considering whole augmented matrix, there are also 3 rows. In first row there is leading element 1, in second row this is leading element this, and in third row also this is the leading element. Therefore, rank of augmented matrix AB is also 3. And as row A equal to row AB, the system is consistent. Now, one example, is a 3, 4, minus 2 a solution of the system 5x1 minus x2 plus 2x3 equal to 7, minus 2x1 plus 6x2 plus 3x3 equal to 0, minus 7x1 plus 5x2 minus 3x3 equal to minus 7. We shall substitute the values in this equation. X1 equal to 3, x2 equal to 4, and x3 equal to minus 2. For first equation, 5 into 3 minus 4 plus 2 into minus 2. That comes 5 into 3, 15, 15 minus 4 minus 4, 15 minus 4 minus 4, 15 minus 8 equal to 7. Therefore, first equation is satisfied. We shall check second. Minus 2 into 3 plus 6 into 4 and plus 3 into minus 2, that is equal to minus 6. 2 into minus 3 is minus 6. 6 into 4 is a 24, and 3 into minus 2 is minus 6, and 24 minus 6 and minus 6, 24 minus 12 is equal to 12, but second equation it is given as 0. Therefore, second equation is not satisfied, and if any one equation is not satisfied, then the system doesn't have solution. Next example, for which values of h and k the following system is consistent? We shall try to write augmented matrix. 2 minus 1 EH minus 6 3 K. Now we shall write this in triangular form. Therefore, we shall try to make this element 0. This element can be made 0 by multiplying 3 times to the elements in first row. 3 times R1. R2 plus 3 times R1. What happens? First row remains as it is. Minus 6 plus 2 into 3 plus 6 0. 3 plus 3 into minus 1 0 and K minus 3H. System will be consistent if rank of both matrices is same. What is the rank of AB? What is rank of A matrix? Rank of A, we shall write A matrix here, 2 minus 1 0 0. Therefore, rank of this matrix is 1. And rank of this augmented matrix is 1 or 2. When it is a 1, if this element is 0. When it is a 2, if this element is non-zero. But as a system is consistent, the rank of AB must be 1. For that purpose, this K minus 3H must be 0. K minus 3H must be 0. That means K equal to 3H. For these values, the system is consistent. That means we can get different pairs of H and K. If you take H equal to 1, we will get K equal to 3. If we take H equal to 2, you will get K equal to 6. For H equal to 3, K equal to 9. Thus, the pair of HK which satisfies this equation gives the system consistent. Dear friend, if you are not subscribed to the channel, let's subscribe it and don't forget to press bell icon so that the updates from the channel you will get. Thank you. See you in next video.